Okay, let's look at the section 8.5. This section talks about congruence modulo n as equivalence relation, right? So let's look at that, right? So we're gonna define equivalence relation as this: A is related to B if A is congruent to B mod n, and n is just an integer greater than or equal to 2. All right, so let's check all three properties. All right, so let's look at the reflexivity. All right, so first, all right, so we have to show that for all integer A is related to itself. All right, so I'll just choose any, say A, in the set of integers, right? So this is just given. Justification is given, right? 2. All right. Then we want to show that A is congruent to itself, but let's see. We know that n divides, so A, let's look at A minus A, right? A minus A is 0, so 0 is certainly divisible by n, right? So n divides 0, so therefore n divides A minus A. By definition, A is congruent to itself mod n. Right, that just comes from line number 2. Right, so since A is congruent to A itself mod n, so therefore, so conclusion is, all right, so therefore, we know that by definition of this relation, A is related to A by this relation R. Right, so this comes from line number 3. Right, so this will verify that it is reflexive. Right, so let's check symmetry. Right, so first line would be, right, we assume, right, assume that say A is related to B by this relation R. All right, then by definition of this relation, this implies that A is congruent to B mod n. All right, so justification for the first line, this first one is given. All right, then this just comes from line 1, and of course the definition here. All right, and 3. All right, so this just means that n divides the difference A minus B. All right, so that comes from line number 2. All right, then 4. All right, so n divides A minus B, so we know that there must be some integer k such that A minus B is equal to n times k. Right, so that comes from 3, right, just the definition of divisibility. And then 5. All right, since we're interested in we want to say A is related, B is related to A, so we're going to do B minus A. Right, B minus A is simply a negative of A minus B, so this is actually negative nk, or we can rewrite it as n times negative k. Right? So that comes from just the 4. All right. So you can see that b minus a is a multiple of n. So 6, we know that n divides quantity b minus a. Right? So that comes from line 5. All right. And then, so we know that by definition of congruence, b is congruent to a mod n. Right, so that comes from line 6. Right, so therefore, 8, we know that b is related to a by this relation r. Right, and this is what we wanted to say. Right, so if a is related to b by this relation, b is related back to a, so it's metric. Right, so we have that. Right, then transitivity. Right, so 1. Right, assume that a is related to b and b is related to c by this relation r. Right, so this is just a given. Right, 2. Right, which means that a is congruent to b mod n, and b is congruent to c mod n. Right, so that comes from line 1, right, and 2. Line number 3. All right, so this means that n divides quantity a minus b, and also n divides quantity b minus c. Right, that comes from line 2. Right, line 4. All right, so which means that this means that a is congruent to b mod n, and also b is congruent to, oh actually, sorry, I'm going back, so sorry, don't want to do that. So there exists some integer, say k, and l, which is an integer, right, such that, right, so this guy means that let's say a minus b is equal to n times k, and this means that the b minus c is equal to n times l. Right, that comes from line number 3. Right, line number 5. Right, so since we're interested in a minus c, so we can add these two guys together. So a minus c can be obtained by adding a minus b and b minus c, because b and the negative b cancel out. But this is just the sum of nk and nl, right, which is just n times k plus l. Right, so we can see that it's a multiple of n. All right, so this comes from, I don't have a room, so it comes from line 5, actually line 4, sorry. All right, line 6. right? So this means that n divides a minus c. So that comes from line 5. And line 7, this means that a is congruent to c mod n, right? That comes from line 6, right? Then 8. Therefore, we know that a is related to c by this relation R, right? Right. So this so since if A is related to B and B is related to C, then we could conclude that A is related to C. So this relation R is transitive. Right. Right. So combining all three, since R possesses all three properties of equivalence relations, so therefore, so we can say hence R is an equivalence relation on the set of all integers. Okay? All right, that's it. I hope that this was clear.